You might have seen me do this topic um 2 days ago. Like I did a question and I used this technique on the question like 2 days ago. Maybe you remember it, maybe you don't. It's okay. All right, so let's jump into today's lesson then. Nothing crazy. So I want to start with a little blast from the past, right? So what's the answer for A over here? A is in parentheses -9 squared. What's that answer? What? You can say it. Yeah. 81. Perfect, right? And the reason why it's 81 is because this is actually -9 times -9, right? How about B? Right? This is -9 squared. What's the answer to that? Almost. -81, right? Because remember, this is actually -1 times 9 times 9. All right? All right, how about C? What's the answer to that? Say it again? 27? No. I'm not gonna lie, I thought it was 27 at first too, though. hmm -729. Right? Sound like a savings plan, right? So the reason why this is -729, this is actually -9 times -9 times -9. So you know the first two -9s, that's gonna give you a -81. No problem. I mean, excuse me, that's gonna be a +81, excuse me. No problem. But then when we multiply that other -9, that's what makes the final answer all negative, right? So -729. Questions on this? Just a little blast from the past. Nothing crazy. Whoops. Hold on. Okay, there we go. All right, this is real simple right here. It's gonna help you with your homework also. Just tell me what the answer is. It says we want to round 3.846 to the nearest hundredth place. Hmm? Yeah. What do you think? No, go ahead, say it. It's probably right. 3.9 hundredth. Yeah. What you think, Warren? Uh, we Good. That's it. 3.85. So when we have this number here, 3.846, right? Remember that this is called the ones place. This is your tens. Oh, TENTS, THS, right? Your tenths. This is the hundredths. And this one is a thousandths. Thousandths, whatever, with a THS. Right? Mm, in a way, it'll help you with your homework, right? Just knowing the place values of numbers, right? If there was another number here, let's say that I had a 5 here for 53, this would be my tens place, right? Let's say I had a 6 here for 653. This is my hundreds place. Let's say I had a 7 here. I'm just making up stuff right now, right? For like 7,653. This is my thousands place. A and D, thousand. All right. Not too bad, right? You remember this, everybody? It's our place value with numbers and stuff. On your homework, it might ask you to round off to a specific decimal place. So this is the name of the decimal place, so you know where to round off. And you remember the rule, right? You look at the next number. If the next number is 5 or bigger, you round up. If the next number is like less than 5, you just chop it off, truncate it. That's it. All right. It's a real blast from the past. It's going all the way back to test one. Yeah. What's the answer for A? I have x to the third times x to the third, which becomes x to the sixth, right? Remember, whenever we multiply exponents, we add them, right? 3 plus 3, so x to the power 6. What about B? I have y to the second times y to the second times y to the second. What does that become? Don't be ashamed. You could count your fingers. Y to the 6, right? This becomes y to the 2 plus 2 power, which is y to the 6. Very good. And then C, a little bit harder. I got z to the third times z to the third times z to the third times z to the third. Z to the 12. Very good. This becomes z to the 3 plus 3 plus 3 plus 3, which is z to the 12. Perfect. Any questions on this, anybody? Slow blast from the past, that's all. Nothing crazy. Mm. All right, let's look at what we're going to get into now. Just bear with me a little bit. We got to build a vocabulary a little bit before we get deep into it. You know? But the whole process is really, really simple. So we're going to simplify expressions with roots, right? So we briefly looked at square roots before, right? Remember that when a real number n is multiplied by itself, we write n to the second power, n squared, which is read as n squared. This number is called the square of n. N is called the square root. So for example, 13 to the second power, 13 squared is read 13 squared. 169 is called the square of 13, since 13 squared is equal to 169. 13 is a square root of 169. So this is how we undo a power or a root. So here you go. Here's the sauce right here, what we're doing today. So square and square root of a number, right? So the square of a number is like, let's say if n squared is equal to m, then m is the square of n. The square root of a number, if n squared is equal to m, then n is the square root of m, right? Just going in reverse, right? So just bear with me. We just building the vocabulary a little bit. So notice negative 13 squared is equal to 169. So negative 13 is also a square root of 169. Therefore, both 13 and negative 13 are square roots of 169. So every positive number has two square roots, one positive and one negative. What if we only wanted the positive square root of a positive number? We use a radical sign and write the square root of m, which is denoted as the positive square root of m. The positive square root is also called the principal square root. This symbol, as well as other radicals to be introduced later, are grouping symbols. All right. So we also use the radical sign of the square root of zero. Because zero squared is equal to zero, the square root of zero is equal to zero. Right. So notice that zero has only one square root, not two. All right. So here we go. Square root notation. The square root of m is read as the square root of m. If n squared is equal to m, then n is equal to the square root of m for n greater than or equal to 0. Right? So this little check looking thing, I call that a house, right? That's your radical sign. Whatever is underneath the radical sign, that's your radicand. All right? So radicand is what's underneath the radical sign. And the little check thing over here, that's the radical, right? Sometimes I call that a house. All right. Questions on this? Anybody? Go ahead.
So radicand is a square.
It is the square, yeah. Mm-hmm. So we know that every positive number has two square roots, and the radical sign indicates the positive one. We write the square root of 169 equal to 13. If we want to find the negative square root of a number, we place a negative in front of the radical sign. So for example, negative square root of 169 is equal to negative 13. All right. Not too bad. All right, let's try this out. There's some basic questions here. So for A, right? What is the square root of 144? What? 12, right? Square root 144 is equal to 12. Right? So you know that 12 times 12 is 144, so I'm going in reverse. And that's how I get that, right? How about B? What's the answer? This is negative square root 289. That's supposed to be a 9. Let me try that again. Okay, that's good. All right. Close. Give me a better answer. Negative 17. That's good. All right. That's it. So that was a little bit hard. 289 is 17 squared. Yeah. All right. How you guys feel about this topic? You feel good, or do you want to see another one? Good? This is like majority of your homework. So, all right. So here's a question. Can we simplify the square root of negative 49? Is there a number whose square is negative 49? I.e., I'm asking, is there some number I can take the square of to equal negative 49? Any positive number squared is positive. Any negative number squared is positive. There is no real number equal to the square root of negative 49. The square root of a negative number is not a real number. All right? Let's remember that, right? So let's start off with A. Give you an example. The question is, what is the square root of negative 196? What's the answer? Right? So this is not a real number. That's it. Literally in your homework, you're going to type in not a real number, and that's it. All right. What about B, though? A little bit more complicated. What's negative square root of 64? What you got? Negative 8. Good. And that's it. All right. Notice the difference, right? The negative's on the outside of the radical, so that's legal. But when the negative is inside of the radical on in the radicand, not a real number. Questions on this, anybody? Are we good, or y'all want to see another one? Okay. All right, I need y'all to bear with me for a second with this next one. We're just building some vocabulary here. Just got to build some vocabulary. All right. So we're going to review some vocabulary. So if we write n squared, that's pronounced n squared, right? Means n times n. If we have n to the third power, that's called n cubed, right? That's what third power means, cubed. N to the fourth power is just n to the fourth power, n to the fifth power is n to the fifth power, right? So whenever I say squared, I mean that the power is two. If I say cubed, I mean that the power is three. Okay. So the terms squared and cubed come from formulas for areas of a square and the volume of a cube, right? So here are some perfect, what's the word for this now? Powers, right? That's a good word. Here's some perfect powers, right? So let's say that n was one, for example, right? Then n squared, n to the second power is just one, n to the third power is one, n to the fifth, you get the idea, right? Now it gets more interesting. Let's say that n was two, then you know that two to the second power is four, two to the third power is eight, two to the fourth power is 16, two to the fifth power is 32, so on and so forth, right? Here's a chart of your perfect powers, right? And then we also have a negative chart, right? So let's say I had negative two, right? Negative two squared will give me four, but negative two cubed will give me negative eight. Negative two to the fourth power is positive 16. Negative two to the fifth power is negative 32. So notice that whenever I raise a negative radicand, right, to a odd power, 1, 3, 5, etc., right? The answer is negative. But when I raise a negative radicand to an even power, 2, 4, 6, you get the idea, right? The answer is an even number. All right. Something to keep in mind. Mhm. Yes, it can. Yeah. Right. So she was saying, Catherine was saying that her calculator can do this. So if you guys bought that calculator, y'all good to go. You know? Yeah. Yeah. Oh, she was saying that her calculator could do it. Yeah. So yeah. So I'm saying, you guys can use it. All right. Notice the signs in the table. All powers of positive numbers are positive, of course. But when we have a negative number, the even powers are positive and the odd powers are negative, right? So we'll copy the row of powers of -2 to show you this, right? So if n was -2, n squared is 4, n cubed -8, n to the fourth 16, n to the fifth -32, right? So even power, positive result, odd power, negative result, right? Just some cool stuff, some cool stuff. All right, continue to bear with me. We still building the vocabulary a little bit, but we're gonna get back to examples soon. Don't worry. All right. So now I want to talk about the nth root of a number. So if b to the n power is equal to a, then b is an nth root of a. The principal nth root of a is written as the nth root of a, right? N is called an index of the radical, right? So you know how we say square root, cube root, and all that, right? So we're talking about different indexes, right? Okay. Just like we use the word cubed for b to the third power, we use the term cube root for the cube root of a, right? So we can refer to this table for higher roots. So for example, 4 to the third power is equal to 64. That therefore the cube root of 64 is 4, right? 3 to the fourth power is equal to 81, right? Remember, that just means 3 times 3 times 3 times 3. So the fourth root of 81 is 3, right? -2 to the fifth power is -32. So the fifth root of -32 is -2, right? So could we have an even root of a negative number? We know that the square root of a negative number is not a real number. The same is true for any root. Even roots of negative numbers are not real numbers. Odd roots of negative numbers are real numbers. Okay? So basically, what they're trying to say, if your root is an even root, 2, 4, 6, 8, right? You cannot take an even root of a negative radicand. That's all it's saying. And if you see that in the future, the answer is not a real number. Okay. Also, if you're wondering, yeah, this is on your formula sheet. All right. So nothing to memorize here. So now we're going to talk about properties of the nth root of a. So when n is an even number and a, the radicand, is greater than or equal to 0, then the nth root of a is a real number. But when a is less than 0, the radicand, right, then the nth root of a is not a real number, right? That's simple. And you just type it in the homework just like that, not real. Boom. When n is an odd number, right, the nth root of a is a real number for all values of a. right? So if you have an odd root here, 3, 5, 7, etc., right? And your radicand is negative, you're good. You're gonna get out a good answer, right? If it's positive, you're good. You're gonna get out a good answer, right? Only when it's odd. If it's even, then we have issues. All right. And that's it. So let's try this out. So what's the answer for A? What is the cube root of 64? Go ahead. Yeah, it is 4. Cube root of 64 is 4. That's because 4 times 4 times 4 is 64. That's where that comes from, right? How about B? A little bit harder. What is the fourth root of 81? Good. That's the answer. Because 3 times 3 times 3 times 3 is 81. Right? What about C? Oh, this is an easy one. What is the fifth root of 32? What is it? Very good. Yeah. And that's it. That's because 2 times 2 times 2 is 81. Get the idea. Questions on this? Anybody? Good. All right. It's not a bad topic, right? Let's try another example. Nickelodeon. Okay, so what's A? A is the cube root of negative 125. What's that? We all live in New York. We should know this. Go ahead. No, it's no. Negative 5. Right? Negative 5 times negative 5, 25, and then 25 times negative 5, that's negative 125, right? How about B? Oof, that's a little hard. 4 through to 16. What do we think? Because the negative's on the outside, that's why. So that's legit. Yeah. What do we think? What's the fourth root of 16? It's a small number. 2. This is negative 2. All right. All right. How about C? Not too bad. I have the fifth root of negative 243. What's the answer? Hmm, that's interesting. 243, yeah. So fifth root of negative 243 minus 3, right? Negative 3. Fifth root. Yeah, yeah, yeah. Yeah. So it's because, negative 3 times negative 3 times negative 3 times negative 3 is negative 3. That's how you get that. All right. Questions on this? Anybody? Okay. All right. Last topic for today. And this is going to be like really, really cool. It's really, really cool. So check this out. So now we're going to talk about how to estimate and approximate a root, right? So when we see a number with a radical sign, we often don't know about its numerical value. While we probably know that the square root of 4 is equal to 2, right? What is the value of the square root of 21 or the cube root of 50, right? In some situations, a quick estimate is meaningful, and in others, it is convenient to have a decimal approximation, right? So, to get a numerical estimate of a square root, we look for perfect square numbers closest to the radicand, right? To find an estimate of the square root of 11, we see that 11 is between the perfect square numbers of 9 and 16, but it's closer to 9, right? So its square root then will be between 3 and 4, but closer to 3, right? So, for example, right? You know that in the perfect square numbers, right? We have 4, 9, 16, 25. 11 is in between 9 and 16, right? But it's closer to 9. Well, the square root of 9 is 3, and the square root of 16 is 4. So what does that mean about the square root of 11? I don't know what the answer is, right? You could do it in your calculator and see the answer. But the point is that it's going to be some number between 3 and 4, but closer to 3. 3.5. No, not 3.5. That's too much. I'm sorry. 3.2, 3.3, something like that. I don't know exactly what it is, but you can estimate what it is. That's the point, right? Same thing with, like, let's say the cube root of 91, right? So we know that our perfect cube, 4 to the third power is 64, and 5 to the third power is 125. 91 is in between the two of those, so we know that the cube root of 91 is somewhere between 4 and 5. We don't know exactly what it is, but we know the answer is 4 point something, right? And then that's it. We're just estimating roots. So let's try this out. Real simple, right? So I have square root of 105, right? This is for A. Square root of 105, right? Now, again, I'm looking at the radicand, right? I know that 100 is a perfect square, right? Right? And then what's the next one after 100? I think it's like what, 121, right? Remember, 100 is what? 10 squared, and 121 is what? 11 squared, right? So 105 is in between those two, right? So I know that this is going to be something between 10 and 11, right? The answer is 10 point something. I don't know exactly what it is, but it's 10 point something. It's going to be close to 10 though. Maybe like 1001, 1003, 10.2. All right. Something, you know? And we're going to do the same thing with B. So they want to know, what is the cube root of 43? I don't really know, right? But I could go through my perfect cubes and then see what I could find. So let's see. We have 2 cubed, we know is 8. That's not going to work. 3 cubed, what's that? 27? Nope, that's not it. 4 cubed, what's that? That's 16, 32, 64. All right, so boom, we know that's going to be between 3 and 4. I don't know exactly what it is, but I know that the answer for this is going to be something like 3 less than the cube root of 43, which is less than 4. All right? And 43 is kind of middle-ish, you know? Maybe like 3.5 or something, or 3.6. What you got? You did it? What is it? Oh, yeah. What? 3.503? Okay, okay. Yeah, something middle-ish. All right. Oh yeah, yeah, that's fine. That's fine. So the whole idea here is that like if you didn't have the calculator, you wanted to estimate what it would be, it'd be between these numbers. And this is just how you do it. You look at the perfect squares or perfect whatever you're looking at, right? And you find where the radicand would fall in between. And then you can estimate it. You're not gonna get the actual answer, but you could say it's got to be between these two numbers, so something point something, you know? Yeah. And that's it. Any questions? Go ahead.
Have question is,
On test three. Yeah.
so just that, I mean, had it like this would be, it exact answer, or is it be less than this?
Like between this and this. Yeah, that's fine. Yeah. I mean, if you see the answer on the calculator, if it's 3.5, then you know it's between 3 and 4. So, you know. All right, that's it for today though. So yeah, we good. Y'all can use the rest of the time to do your homework though if you want. All right. Okay. Can I take this down? Is that okay? Thank you. Yes, I got you. On my phone, my phone. Go ahead. I'm sorry. Oh yeah, yeah, yeah. Yeah. Well, come over. Let me show you. Good. Okay. Let me just take this down real quick.